Welcome back. In this lecture, you are going to understand about reactive programming and how Mule is internally using reactive programming. Actually, as you know, Mule is implemented on top of Java. In Java world, there is a specification called as reactive streams. Reactive streams is a specification, and in Java world, there are multiple implementations for this. RX Java is one implementation of this specification, and one more thing is a project reactor. So project reactor or RX Java are frameworks implementing this specification, and this project reactor is used by a framework called as Spring also internally. Okay, and Mule is developed on top of Mule 4 is developed on top of Spring. So I can say that Mule is using reactive programming model. So let us try to understand what is this reactive programming. Actually, in reactive programming, it uses observer pattern. This is a design pattern, if you know. According to observer pattern, there will be two objects actually. One object is an observable, which can be observable, and another component is an observer. Okay, two components, observable and observer. Actually, observer, what it will do is it has to subscribe to the observable. So for one observable, it is possible that there can be multiple observers. Okay. Now, let's assume that this observable is a component which is polling a database at regular intervals. Let's assume that it polls the database after every 1 hour. So once it polls, it will get, let's say, 100 records. Now, what this observable component can do is, for each record, it can iterate over the cursor given by the database. For each record, it can invoke the observer and notify the observer, I can say. It can invoke the observer and pass it. Actually, observable calls a method called as on next on the observer whenever data is available. So this observable, if there are 3 observers, it will invoke all the observers and emit the data, I can say. Or I can say observable is pushing the data. It is a push model. Observable, whenever it has some data, it will push that data to all the observers. So one of the thread will be actually polling the database, right? So let's say this is a main thread. Normally, what we can do is the main thread which polled the database can invoke all the observers, right? But it is possible that we can configure a scheduler. A scheduler is a component which is backed by a thread pool. So what we can do is we can make this observable to push the events to the observer using this thread pool. That means the observable will submit a task to the scheduler and ask it to schedule that event. Scheduler will use one of the thread in the thread pool to notify the observer. Okay, so let us see some more concepts before I go to actually Mule how it implements. Now let's assume that observable, once it gets a record, it is taking some 3 seconds to process that record from the database. Whatever is pushed by the observable, for processing the data, it takes 3 seconds. And let's say observable has got 1000 records. What the observable will try to do? It will try to push all the events to the observable, 1000 events to the observer. But observer component might be busy. It may be processing at a it's taking more time. Let's say 3 seconds is more time, right? So the rate at which the observable is emitting the data is not same as the rate at which observable can consume the data, right? So it may be possible that observable will push lot of events and observer will become slow. So there is one more concept in reactive programming. Actually, whenever observer subscribes to an observable, it will get a subscription object. It will get an object called as subscription. So using the subscription, the observer can tell to the observable how many events to push. Let's say it can say to push 20 events, right? So when this observable has subscribed, it is saying, okay, to me, push 20 events at once. Don't push more than 20 events at once. Once I am done with 20, then again I will ask you to push next 20, right? So observer 1 can say, okay, please push 20 elements, and after 20 elements are over, don't push any other elements until I again ask for next 20, right? So observer 2, this can actually ask, okay, push me 40 elements. This can ask for 50 elements, right? So if the observer component is slow, it can put a back pressure on the observable. This is called as back pressure. Back pressure. It can put back pressure on the observable and ask, hey, I'm very slow, so don't send me only 20. And let's say the observer even became very slow. It is processing maybe one record in 5 seconds. Then we can actually configure observer such that it can request for maybe 10 elements only, 10 elements only, right? So an observer can put a back pressure to the observable and say emit only 10 elements. Then once 10 elements are consumed by the observer, it can ask for, okay, emit 10 more elements. So by using back pressure, the observer can tell to the observable at what rate to push the events. So this is really good technique which Mule also uses. So this is this is reactive programming. Hey, you are asking me what is reactive in this case? It's nothing but observer pattern, right? So not only observer and observable, as I told you earlier also, this is observable, let's say, and this is observer. Now whenever observable is calling the observer, same thread will by default call, but instead we can configure a scheduler which is backed by a thread pool. So whenever observable wants to push any data to observer, the main thread, this main thread will not push. It will submit the task to the scheduler, and scheduler will use another thread in the pool to execute it, right? So like that, every observable can have a scheduler which is backed by a thread pool. Now once you understand this, let us come to Mule. So in Mule, what we do is we have a flow which contains all the components like this, right? So actually this is, let's say this is source component in our Mule flow. This is an observable. The next component in the flow will subscribe to this observable, and this is an observer, right? But it also implements another interface called as observable also. Every component in Mule is both an observer and observable. So this component, let's say I'll name it A, B, C, D. So B is an observable, B is an observer to A and also is an observable. Now C will become an observer to B and also it is an observable. Right? It will subscribe to B. So it's an observer to B and also it is an observable. So C will subscribe. C will become the observer to, so D will become an observer to C. This is also an observable again, right? And now what happens? This source component will become an observer. This will become an observer. A becomes an observer to the last component D. Right? This is how actually in a flow all the components will be using this concept of observable and observer. And in Mule runtime, they have configured 3 schedulers. One is 3 schedulers backed by thread pools. So there are 3 thread pools I can say in Mule 4 runtime. One is named as CPU light thread pool. And another is CPU intensive thread pool. And another thread pool is blocking IO thread pool. So in Mule runtime actually they have configured 3 thread pools. Okay. Now B is an observer to A, right? Suppose if B is a component like a database component which is talking to a database. So that means B is a component which is doing IO operations, right? Input output operations. It will take more time, right? And let's assume that C is a component which is a transform message component which is doing a lot of CPU intensive operations. That means data wave, it will actually execute a lot of transformation logic, is it? So component C is a transform message, let's assume, and component B is a database component. So if this is the case, what will happen is, as I told you, when B subscribes to A, Mule will identify, okay, B is a database component which is doing IO. So here in this case, a blocking IO scheduler or the scheduler backed by a blocking IO thread pool will be assigned to A. So whenever A wants to push some data to B, it will do so using a thread present inside this blocking IO thread pool. So the database component, now in this case, will be executed by a thread in the blocking IO. Okay. Then what? B has to again push the event to C, right? But C is doing what? CPU intensive operation. This is a transform message component. So they know, okay, transform message component does a lot of CPU intensive operations. So actually B will push the events to C using a thread pool called as CPU light thread pool. Okay. Sorry, CPU intensive thread pool, because this is doing CPU intensive operations. That means this transform message component will be using CPU intensive thread pool. Okay. And let's say there is another component in between here, E, which is a logger or some component, let's say set variable or set payload transformer it is. Set payload transformer, it's just not executing any CPU intensive operation, or it is not even doing IO operation. It is just setting the payload, right? So this component is neither doing CPU intensive operation or IO. So here component A will use CPU light thread pool to push the events to E, if there is E between A and B, okay? So like that, in a flow, all the components in a flow will be executed by one of the thread from the 3 thread pools. Okay. Okay. Let us take one more example. Let's assume that this is a flow where I have HTTP listener component, and next one is a logger, and next one is a database select component. Okay, and next one is a transform message component, and again next one is insert component, and yeah, that's all. Okay, so now let's assume that this is a flow, and as I told you, there are 3 thread pools. Let us see which thread from which pool will execute each component. In this case, this is CPU light, this is CPU intensive, and this is blocking IO. By default, if you don't configure, in CPU light thread pool, there will be 2 into number of cores, and for CPU intensive also there will be 2 into number of cores in your machine, cores of CPU. And for this blocking IO, there will be this thread pool will be bigger in size. It uses some formula. I'll show you that formula. Based on the formula, it will decide how many threads to be present inside this thread pool. These are the default settings, right? If you know, in Mule there is a file called as schedulerpools.conf. Schedulerpools.conf in the conf folder of the Mule runtime. So if you want to customize these thread pools, you can customize the properties inside schedulerpools.conf. I will show you later. But now, one more thing you need to understand is this HTTP is a message source of this flow, right? For message sources, there will be a separate thread pool. Okay. So in this case, HTTP component will use one more framework or library called as Grizzly. So HTTP component is internally using Grizzly. So it will use a thread pool called as Grizzly thread pool. Okay. So what will happen is, in Grizzly thread pool, we have to configure something called as selector runner threads. Selector threads, I'll say. Selector runner threads we need to configure. This also can be configured at the HTTP component level, right? So as of now, let us don't worry about how to configure. HTTP component is internally using Grizzly. We'll talk about Grizzly in my next video. So as of now, to introduce, Grizzly is a framework or a library which allows you to create non-blocking IO servers. So Grizzly internally uses NIO, non-blocking IO, so that the data, the threads will not be blocked waiting for the data, right? So now let's assume that from any HTTP client, let's say this is a client application, let's say it's a browser. Whenever a new request comes to the browser, from the browser to the HTTP, there will be a listener thread, right, which will be listening on a port. So whenever request comes from the browser to HTTP component, it will come to listener port, and listener, what it will do is it will delegate the request processing to a selector thread. Okay, so selector thread will actually be automatically used in HTTP. Now, what this selector has to do, it has got a HTTP request, and this is an observable to this logger, right? So it has got a HTTP event. This is an observable, right? So now the HTTP component has got a request. So whenever request comes, the listener will delegate to grizzly selector thread. What it will do is it will create a mule event object. Okay, as you know, in Mule it is creating a mule event object, and it will try to push the mule event to the next component, right? The selector thread, grizzly selector thread, will try to push it to the next component, but next component is a logger. Logger by default is a lightweight operation. So the HTTP listener, this component, will use a thread from this CPU light thread pool and push the event. So who will execute the logger in this case? A thread from CPU light thread pool will execute the logger. So logger, let's say it is writing a log. Then what? Then the next component is database component. This is an observer to this one, right? So since this is a database component, Mule will decide, okay, this is doing CPU intensive operation. So logger will use a scheduler which is backed by this pool. So a thread from the CPU intensive thread pool will invoke the database. So who will execute this database component? CPU intensive thread will execute the database component. Then once this is done, it has to push the event to the next component, transform message component, right? Again, which thread pool? This transform message means, I just made a mistake. Database component is doing IO operations, right? So logger will push the event to database component using blocking IO thread pool. Okay. Then transform message is doing CPU intensive operation. So through which thread pool will this component push the event to transform message? Using CPU intensive thread pool. So who will execute this transform message? CPU intensive thread pool. Then again insert. This is again IO. So again, who will execute this database insert? Blocking thread pool, right? And then for this last component, who is observer? HTTP component is a observer. So this observable will push the Mule event to HTTP component. That's how the HTTP component again gets the response back. But now it will identify this got notified for which request based on the Mule event ID and all, right? It will actually correlate. Okay, I got this invoked because of which event. It will correlate the Mule events and it will identify and it will send the response back to the client. So this is how a Mule flow internally uses all these thread pools for invoking your flow. Actually, in my next video, I will show you how an example of how these thread pools are being used practically, and I'll show you the lab. Hope you are getting good confidence on how Mule is working internally. Actually, before I show you demos, in my next video, I'm going to tell about what is this non-blocking IO and how the components in Mule will use non-blocking IO. Once you are good at understanding non-blocking IO, we'll see with an example. See you in my next video.